This tutorial will help you with the first genetics assessment on meiosis. So in the question, you're given a genotype for a baby, for some type of offspring. And for this example, I'm just going to say the genotype is big T, and little a, little a. Okay, and the question is, what had to happen in meiosis and fertilization in order to get this genotype in the offspring, or in the baby? So let's start by working our way backwards. So if that's the baby, that means that the egg and the sperm that created that had to have in them the following chromosomes. In the egg, there had to be one chromosome with a big T on it, and there had to be one chromosome with a little a on it. And then in the sperm cell, there had to be one chromosome also with a big T on it, and one chromosome with a little a on it. Okay, when you put those together, that ends up being this big T, little a with 4 chromosomes. Now, how did we get to that through meiosis? We'll look at the egg first. So remember, in meiosis, you don't just make one egg, you make 4 eggs. So I'm going to draw those 4 eggs. And as I said before, they each had in them a big T. And I'm going to show that here. And then they each had in them a little a. I'm going to show that here. Okay, remember that these 4 cells each came from 2 cells. Okay, that's split into 4. And those 2 cells had sister chromatids in them. So the sister chromatids in this cell were the big T sister chromatids. So each of these chromatids had a big T on them, because remember, they're copies of each other. And each of these chromatids had a little a on them because they're copies of each other. And the same thing's going to be in the other cell. Now remember, each of those 2 cells came from one cell, so we're going to work our way back to the original cell. And in that original cell, we had our homologous pairs. So those big T homologous pairs were lined up across from each other. So there's the 4 big T's, and the little a, 4 little a's, as a homologous pair lined up across from each other. Okay, so again, that's how we got the egg cell. Remember, it was just one of these that ended up making our original individual. Now the sperm cell, because the sperm cell also had a big T and a little a, would be made in the same way. And then you take that sperm cell and that egg cell and put them together. So on this assessment, you're going to have to pay close attention to the original genotype. Okay, so in my original genotype, I had big T, little a, and so I had to figure out how that came together. But if you had a different genotype, it would look different. So let's take another example of a genotype. So let's say we had little a, little b. That again means that in the egg, there must have been a little a chromosome and a little b chromosome. And in the sperm, there must have been a little a chromosome and a little b chromosome. And then when they came together, they gave the baby these 4 chromosomes. Okay. We take a different genotype. Let's say big D, big R, little r. That means in the egg, there had to have been a big D chromosome and a big R chromosome. And in the sperm, there had to have been a big D chromosome and a little R chromosome. So when they come together, they would create those 4 chromosomes in the offspring, in the embryo. Okay? And then once you know what the sperm and the egg are, you can use that same pattern in meiosis that I showed earlier to figure out what the original cells were. All right, so that should help you through that first genetics problem. If you have any questions on this, you can send me a message individually through Schoology, and I'll see if I can help you with more specific problems.